Assalamualaikum. My name is Syahira and I am from Group E. And today I would like to explain about our group project that is optimizing machine learning algorithm using genetic algorithm of PCOS. And here are the contents of our presentation, that is introduction, methodology, EDA, models and conclusion. For introduction, we have problem statement. The first one is we need accurate and timely diagnosis of PCOS for effective management. The second one, we need for improved diagnostic tools to enhance accuracy and reliability. And the objective of our project is to enhance the test accuracy of machine learning classifiers used for PCOS diagnosis by employing genetic algorithm. And our dataset is from Kaggle, that is PCOS.csv, and it went through data handling, missing values, and feature scalings. For the methodology, we will go through a lot of process before we get the classification. The first one, we will do the data collection and data equation from Kaggle. And in here, we will choose the best one data set that we will tune. And after that, we will go through the data pre-processing standardization, where we will do EDA and remove all the things we don't want. And we will do the next one, we will do model selection, that is SVM, random forest and logistic regression. In here, you can tune the parameter here and we will get the accuracy test. And after that, we will do the model evaluation, that you can see the evaluation matrix, that is accuracy, precision, recall, and F1 score. And after that, we will do the hyperparameter tuning with genetic algorithm, and you can see the accuracy score after that. And by that, we can get the PCOS classification.
What we did in EDA to shape the dataset until it becomes suitable for processing is we did some null value checking and dropping not needed columns to make the dataset smaller, since the dataset that we pick is high dimensional. This is the correlation heat map of our data before and after EDA. We managed to simplify the dataset from 539 rows with 44 features to only 28 important features. Let's go through the coding together. For machine learning models, we choose to implement the first one, support vector machine, that handles complex decision boundaries. The second one, random forest, assemble method for robust classification. And the last one, logistic regression, a simple and effective algorithm for binary classification. The optimization technique that we use to tune the hyperparameter is genetic algorithm based. For the first base model, which uses logistic regression, I'm focusing on two hyperparameters, which is value C and solver. Value C is the inverse of regularization strength, and solver is an optimizer. Max iteration is set to 1000 and ensure the algorithm has enough iteration to converge. At first, I've set the value randomly, which is C to 5 and solver to LFPGS. After testing and training the model, the cross-validation accuracy is 0.8773, the test accuracy is 0.8889, and from the classification report, we can see that the accuracy of the model is 0.89. Now we are implementing GA into logistic regression default model, and after implementing the GA to the default model, we attain the best individual to be the value C is 8.9748 and the solver is LBFGS. And we can see that the cross-validation accuracy now is 0.8773 and the test accuracy is 0.8951. And the accuracy by classification report is 0.90, which is increment by 0.01 in accuracy compared to default model.
Assalamualaikum, my name is Siti RAIHANNAH, metric number 2219358, and I'll be presenting the coding for random forest classifier, where first and foremost we need to import the necessary libraries, where the cross-val score function is used to evaluating the model's performance using cross-validation. And then we use the random forest classifier, which is the machine learning of model that is being used for the classification. And then we import the function for evaluating the model performances, such as accuracy score to calculate accuracy, confusion metric to create the confusion metric, and also the classification report to provide detailed report on precision recall, F1 score, and etc. And then we also import the SNS to visualize the things, and then as well as the matplot to create plot. And then we initialize and train the model, where the N1 job is to use all available processor cores for parallel processing, and the estimator is we have initialized to 150, which is it will create 150 decision trees in the forest. Max feature square root is the total number of features when looking for the best split, and also the minimum sample leaf is 10, which is the decision tree must have at least 10 samples. We then perform the cross validation on the training set, where it perform five-fold cross validation on the training data, X train and then also the Y train, using the random forest model, and it calculates the accuracy for each fold, where the accuracy will then be stored in the CV score. We then go ahead print the cross validation score as well as the mean accuracy. Next, we evaluate the model. Before that, we then train the random forest on the entire training data, which is the X train and then Y train, and then we evaluate the model, where uses train random forest model to predict target variable for the test data X test, and then the prediction are stored in the Y test prediction, and then the, the and then if we calculate the accuracy of the model's prediction on the test set by comparing the predicted values, Y test prediction and also the Y test, and then we print the accuracy, and then we go ahead and do the classification report as well as the coefficient matrix. So this is the result. We then got the mean accuracy, CV accuracy of 0.85, and also the test accuracy we have achieved is 0.91. So next will be explaining the code for the code using genetic algorithm for the random forest classifier. Um, First and foremost, we do the evaluation function, where this evaluate function is the heart of the GA, where it takes an individual, which is a set of hyperparameter, and the training validation data. It creates a random forest model using the hyperparameter from the individual, and then it trains the model on X train and a Y train. It makes prediction on the prediction data X value, and it calculates the accuracy of the prediction and returns it as the individual's fitness score. And then we use the genetic algorithm setup, where the toolbar is a container to hold the GA's operator, which is the function. As for the register function, is used to add functions to the toolbox. It defines how to create random value for hyperparameter, attribute and estimator, attribute max features, and attribute mean sample leaf, where it defines how to create an individual, a set of hyperparameter, where also it defines how to create population of the individual. It specifies genetic operators such as the mate, which is the crossover, and then mutation, and select as for the selection. And it assigns evaluate function to the toolbox. And then we go ahead and run the genetic algorithm. The population creates an initial population of 20 individuals. As for the n generation, it sets the number of generation for the GA to run, and then the loop iterates through the generation, which performs algorithm var n toolbox map toolbox evaluate of spring, which evaluate the fitness of each spring, as well as toolbox select, which selects the best to form the next generation. And then we use the best hyperparameter, where the tool cell best gets the best individual from the final population, and then the code is extracted, the hyperparameter value from the best individual, and then it finally trains a new random forest model using this optimized parameter. Um, and then it evaluates its performance on the test set. So we then print out the classification report, confusion matrix, to see um, if the accuracy after we use the GA to the random forest classifier improve. So here we can see that it has improved by 0.04, where the first one we got 0.91 for only using random forest classifier. Now we got 0.95. So here's the summarize of the random forest classifier, which before the tuning with GA and also after the tuning with GA. So for the before tuning with GA, the n estimated is 150, the max feature is square root, and the mean sample leaf is equal to 10, which we got the test accuracy of 0.91. But after the tuning with GA, after using the hyperparameter GA, so the best parameter that is found by generative algorithm is that we get the n estimator 142, max feature log 2, and also the mean sample leaf 2, which we got the test accuracy of 0.95, which is the difference with the before tuning with GA around 0.04.
So next, I would like to explain about our code for SVM classifier. And for the first one, we're gonna import all the things that we need and do the formula for X train scale and X test scale. After that, we will evaluate the best model using the formula for best model, that is SVC. C is equal to 5, gamma is equal to 0.1, and we choose the kernel RBF and random step, that is 32. And after that, we will print the SVM test accuracy and do the confusion matrix for SVM, that is using print all the predicted, actual, and SVM confusion matrix. And after that, we're gonna do classification reports for SVM by using the formula and print all the SVM test classification report. And after that, we will do the cross validation to check the stability of the model by using the CV score formula, and we will print out all the cross validation score and SV score and choose the best cross validation score. And you can see here, as after we run, we get the output there for SVM test accuracy 0.90, and this is the result for test classification report, that is 0.90 for SVM score. And you can get the cross validation score, that is 5 score here, and get the best cross validation score, that is 0.84. And after that, we will do installation for deep, and we will go through the genetic algorithm here. Okay, for the first one, we will import all the things that we need and define the problem, that is a maximization problem that used to higher accuracy is better. And for the first one, we will create the fitness max and individual function. The first one, fitness function, we will evaluate the C is equal to find the gene represents, and gamma to find the gene represents too. And also we will create the SVM model and perform cross validation to return the mean score of the fitness value. And after that, we will do create the population using the create individual, and modify mutation to ensure gamma is always positive. And after that, we will set up the genetic algorithm using the toolbox, and here you can insert what you want and create the population using the toolbox here. So population is based on the toolbox here, but we choose the size is equal to n is equal to 10. And after that, we will do genetic algorithm. The first one is generation is equal to 10. Cross our probability is equal to 0.7 and mutation probability is equal to 0.2. And we will do the run to the genetic algorithm here, and we will apply crossover and mutation for child, child 2 and zip, and for mutant in offspring. And after that, we will evaluate the fitness of individual with invalid fitness value and print the best individual, that is best individual and fitness. And we will extract the best C and gamma values using best individual formula based on this one. And you can get the best C and best gamma here. And after that, we will do the tuning for hyperparameter and get the test set accuracy based on GA, and also the confusion matrix using Seaborn as just now. That is, will print the confusion matrix, predicted labels, and also true labels. And the last one, we will get the test set classification result based on GA. And here you can see it is the generation after we run the genetic algorithm for each individual, that is 10, and we will get the best C, that is 7.96, and best gamma, that is equal to 0.001. For test set accuracy based on GA, we will get 0.925. This is the confusion matrix for the genetic algorithm here, and this is the test set classification report based on GA, that is 0.93. So I would like to say that is there is an increasement here from 0.90 to 0.93 after we tune in the GA for SVM. I think that's all from me. Thank you. The next classifier is SVM. Why we use the SVM model is because it is for high dimensional data, and it is useful for classification when data is not in linearly separable. That is for wide algorithm. And here you can see that before tuning the genetic algorithm, we choose the parameter, that is C is equal to 5. C is equal to 5 is for regularization parameter. The next one is we use the kernel coefficient gamma. Coefficient gamma is to decrease the value for broader decision boundary. And for the kernel type, I use the RBF because it is for nonlinear data. And after we run the code, we can see here the SVM test accuracy is 0.90. It is not that high. Compare after tuning GA, when we will choose the best parameter, that is the GA, that is C is equal to 3.89 and gamma is equal to 0.0019. And after we tune in the genetic algorithm, we can see the test set accuracy result, that is 0.93 here. It is so increased in terms of test accuracy.
So as for the accuracy comparison, out of these three, the biggest jump from the before we used the hyperparameter tuning of GA into the classifier is random forest with the difference of 0.04 compared to logistic regression. It jumps from 0.89 to 0.90 with a difference of 0.02, as well as the SVM, which is the 0.90 to 0.93 with a big difference of 0.03, and the random forest with the highest jump from 0.91 to 0.95 of the accuracy. The conclusion we can get from this whole group project is that The random forest classifier showed us the most significant improvement, which is likely due to its inherent and complexity and the greater flexibility in its hyperparameter, which makes it suitable for to use random forest. Well, this project highlights the potential of combining machine learning techniques with optimization algorithms such as like GA in order to improve the diagnostic accuracy of the data that we are using, which is the PCOS. So this finding can support the development of more reliable diagnostic tools for PCOS, ultimately aiding the healthcare professional in providing better patient care to be used in the hospital.